Hello friends, welcome to today's lecture Losses in Prestress. Myself Mr. Y. S. Patil, Department of Civil Engineering, Shared Technology, College of Engineering, Yatra. So already we know the losses in the pre-stresses. So basically the losses in the pre-stress is defined into two categories. One is immediate, that is short-term loss, and second is a time dependent, that is long-term loss. The immediate losses occurs when the tendons are pre-stressed and the pre-stress is transferred to the concrete part, and time dependent occurs when the pre-stress members are used or in the service of the life. The various types of the losses are listed below. So basically immediate loss, that is short term loss in the pre-stress, is due to the friction. Second, due to the elastic shortening of the concrete. And third one is losses due to anchorage slip. These losses are the short term losses. Then second one is time dependent losses, that is long term losses. So in the long term losses, first is losses due to creep of the concrete. Second one is losses due to shrinkage of the concrete. And third one is losses due to creep of the relaxation of steel. So pre-tensioning and post-tensioning are the two procedure for the imparting of the pre-stressing to the concrete member. Pre-tensioning means what? The concrete is poured after the tensioning of the steel, and post-tensioning means what? Concrete is hardened after apply the tension on the steel. So basically these losses are bifurcated on the pre-tensioning and post-tensioning. Let us see one by one. So first of all we discuss losses in pre-tensioning. So first loss is losses due to pre-tensioning is the losses due to elastic shortening of the concrete. Second one is losses due to creep of relaxation or relaxation of steel. Third one, losses due to shrinkage of the concrete. And fourth one is losses due to creep of the concrete. These four losses are considered in the pre-tensioning concrete. So next one is losses in the post tensioning. So basically in the post tensioning the losses is considered, first loss is a losses due to friction, second losses due to creep or relaxation of steel, third one losses due to shrinkage of the concrete, fourth losses due to creep of concrete, and fifth one losses due to anchorage slip. And one more condition is there in the post tensioning: if the tendon is simultaneously tensioned, then loss due to elastic shortening is not considered. But if the tendons are successively tensioned, then we need to consider that losses due to elastic shortening of the concrete. So let us see one by one loss. So first one is loss in pre-stress due to friction. So this loss due to friction is occurs in the post-tensioning part only. So this part is formed in interface of the concrete and steel. There is a reduction in pre-stress along with the member from the stretched end. The stretching must also have overcome the tendon's oblique in the addition to the friction. The change in the location of the tendon along the duct is referred to as the oval. Means what? When you pass the tendons from the conduits, the friction will be occurs in concrete and tendons, and due to this friction the losses will be generated. Means whatever your applied force is on the concrete is actually less than your applied force. So this is the most important loss in the post tensioning the concrete. So loss of pre-stress due to friction is calculated by formula, that is P by A into Kw into X in plus alpha into mu, where Kw is the oval friction loss, X is a when X is equal to span of that particular beam, alpha is the angle of the tendon in the radian, and mu is the coefficient of friction. Then next, losses in the pre-stress due to anchorage slip. So anchorage is a component that used to attach the tendons to the concrete while terminating them. When the stressing process is over, the major role of the anchorage is transfer the stressing force to the concrete. The tendons are provided into the ducts of the precast concrete member in the case of the post-tensioning system. To transfer the stressing force to the concrete, anchoring is supplied to the at the both ends. of the tendons. If anchorage moves from the original position, the tendon loosens and resulting the pre-stress loss. So this particular loss is calculated by the formula is simply delta L upon L into Young's modulus E for the tendon. So where delta L is anchorage slip in mm, L is the length of the cable in mm, and ES is Young's modulus E for the steel. So next one is losses in pre-stress due to the elastic shortening of the concrete. So this loss is only encountered in the pre-tensioned member. When the tendons are cut and the pre-stressing force is transferred to the member, the concrete undergoes immediately shortening due to the pre-stress. In addition, the tendons shortened by the same amount. So this particular loss is calculated by formula is uh, modular ratio into stress in the concrete at the level of the steel or at the level of the tendon. So modular ratio is nothing but the Young's modulus E for the steel divided by Young's modulus E for the concrete. The next one is the losses in the pre-stress due to creep of concrete. So creep is a deformation that occurs over time due to the constant force. Pre-stress is a permanent force is pre-stressed concrete that causes the compressive stress at the level of the steel level. As a result, the member is under stress. The loss of pre-stress due to concrete creeps occurs in both the pre-tensioning and post-tensioning member. So by considering the following equation, we calculate the losses of pre-stress due to creep of concrete is equal to phi into m into sigma c, where phi is equal to creep of coefficient, m is equal to modular ratio, and sigma c is equal to stress in the concrete at the level of the steel. The next one, losses in pre-stress due to creep or relaxation of the steel. The steel relaxation is described as a decrease in the stress over the time when under constant tension due to the relaxation of steel. The pressure in the tendons is reduced with the time. The stress loss due to relaxation depends upon the types of steel, initial pressure and temperature. Based on the observation, it is considered that 2% loss occurs in the pre-tensioning member and 3% loss occurs in the post-tensioning member. So next one is losses in pre-stress due to shrinkage of the concrete. The stress loss is added by the shortening of the tensioned wire caused by the concrete shrinkage is pre-stressed member. In the case of the pre-tensioning member, moist curing is usually used to keep them from the shrinking until they are transferred. As a result, the total residual shrinkage strain in the pre-tensioned member after pre-stress transfer will be greater than the post-tensioned member, where the portion of the shrinkage will have already occurred at the time of the stress transfer. Thank you.